Okay, so this will be a fairly quick video. We're just going to be talking about finding horizontal asymptotes, and this is pretty straightforward, but you have to know the rules in order to do so. And there's actually three possibilities when you're dealing with a horizontal asymptote, and we're going to talk about those three right now. So if you look up here, they're talking about a rational function p of x, and then it will be n of x over d of x. That's how we're going to describe our rules here. So for example, if you look at the first rule, it says the following: if the degree of n of x is greater than the degree of d of x, there is no horizontal asymptote, okay? The second rule: if the degree of n of x is the same as the degree of d of x, you are going to have a ratio there of your leading coefficients. So whatever the leading coefficient is on n of x, and then whatever the leading coefficient is on d of x, you're going to take a ratio of those two coefficients, and that ratio will be your horizontal asymptote, and we will describe it as y equals. So y equals that ratio, a over b, okay? And then the third rule: if the degree of n of x is less than the degree of d of x, you'll have a horizontal asymptote at y equal to 0, okay? So why don't we go ahead and try three examples covering all three examples here, okay? Let's take a look at our first one. So here's our first example here, and you can see that the degree on my numerator is greater than the degree on my denominator. Right now on my numerator, I have a degree of 3, and then on my denominator, I have a degree of 1, okay? Also, quick note, make sure you are checking the order, because sometimes they may write these out of order. Just because you have your first term here, that doesn't mean that's always going to be your highest degree. This one, it happened to be. But sometimes they may write it out of order, so you have to actually check the exponent values. Don't just go ahead and look blindly at the first term and think that's going to be your highest degree. You have to check all of them. But again, on my numerator, I have a degree of 3. On my denominator, a degree of 1. That means there's going to be no horizontal asymptote. So I'm going to go ahead and say here, no horizontal asymptote. I'm going to go ahead and abbreviate HA, right? No HA. All right, let's go ahead and try another example. So here's our next example, and on this one here, you can see that the degree on my denominator is greater than the degree on my numerator. Right now, the degree on my denominator is 3. On my numerator, it is 1, okay, even though they don't write that, but it is 1. And so what does that mean? Well, that means, again, if you go back to the rules that I gave you, that's going to be a horizontal asymptote at y equal to 0. So HA, horizontal asymptote, is going to be y equal to 0. Okay. All right, let's try one more example. So here's our last example. And on this one here, you can see that I have two quadratics, one on my numerator and one on my denominator, and they have the same degree. They have a degree of 2. So this is where you take the ratios of your leading coefficients. So my HA here, my horizontal asymptote, is going to be the following. It's going to be -5 over 2, because again, those are my leading coefficients. So I'm going to say here y is equal to -5 all over 2. There's my horizontal asymptote, and then you're done. Those are the three possibilities, okay? So again, with a horizontal asymptote, we're talking about an imaginary line that the curve is approaching, but not actually touching. Just keep in mind, you could have your function cross a horizontal asymptote as it goes from -infinity to positive infinity. That happens from time to time, but what you have to understand with a horizontal asymptote, it's essentially describing your end behavior. So as you go to positive infinity, it will not be crossing, right? It will be approaching. And as you go to negative infinity, same thing, it will be approaching, not crossing. But again, don't be taken back if you see that it does end up crossing your horizontal asymptote in between the infinities. That is a possibility. And again, that does happen from time to time. That doesn't mean it's wrong. It just happens, okay? So I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.